Welcome, everybody. Yes, I'm Nicolai Parlog. I'm working as a Java developer advocate at Oracle, but I don't want to bore you with that. Let's just go. So this session focused on Java 22 and 23, and this is a showcase, not a tutorial, because surprisingly, there's a lot of content in here. When I first started setting out the talk, I was like, 23, just like 2 final features, that's not much to talk about. But that's not true if you go through the 22 stuff as well, and to previews, it's actually way too much. In fact, at DevOps Belgium, I felt like 3 hours with this. But I'm confident that you Dutch people are quicker on the take-up, so we can do the same thing in 50 minutes, yeah? If in case there's any detail you missed, go to youtube.com/java, and you'll find videos about all of this, really. OK, so these 5 features got finalized in Java 22 and 23. And this is the part of the program that I really, really want to get through with you, right? So this is the most important parts. Some of them are a little bit longer, some of them are a little bit shorter, but I want you to get this full understanding. So if you're on 21, say that you now know what features are final on 22 and 23. But there's a lot of preview features as well. This is not even all of them. And I got slides for all of those, but I'm pretty sure we're not going to get to all of them, maybe not even any of them. But we'll see, right? So we'll see how far we get down this road. And you can, maybe pick a little bit later when we have the time. OK, so let's start. Let's start with something that's a final feature in JDK 22, and this is about unnamed patterns. And if I only had like 30 seconds to show you the feature, this would be it. And that's all there really has to be said about it. So what you can use an underscore to mark a pattern or a variable or a few other things that you don't actually need as unused. And what that gets you is, first of all, the IDE shouldn't complain about this being an unused variable because it's intentionally unused. But also you can use more than one underscore in the same scope. So if you have like 3 unused variables in the same scope, although why would you, but you might, you can use an underscore for each of them. And that works with the by consumer up there, for example, which can come in handy when Java forces you to implement a functional interface where you don't really need all the variables. Then we have an instance of check where you use a record pattern and to deconstruct the user, and then maybe you only need the name and you don't care about the rest, you can use the underscore there. And then a third example is when you switch over some kind of whatever object and you use the type patterns to say, in case it's a user, do this, and in case it's an admin, do that. But I don't really care about the user or admin instance. I just want to use an underscore there. And that last one is really important. If I only had like 2 minutes, I would be done now. But I want to spend a lot of time going into the last one and why it's important, because I think that's really critical if you're using pattern matching in Java. So let's take a step back. Let's start with a little example. We have a simple app here that scrapes GitHub projects. It creates page instances of GitHub issue page, pull request page, error page, or external page. And then it further has like features built on that. What features could this be? Tons of ideas. The details don't matter. It's just we have some domain types, and we're all of functions or methods or features that operate on them. How do we implement that? Well, you could have methods on page. You could have a method on page that does, for each of these things, probably a bunch of methods for each of these things. And you would see a lot of very different concerns collide in the same type. That is terrible. We don't want that, right? We don't want to have a type that knows the payment system, but also knows like how to draw itself on a 2D canvas. That's terrible. You could use the visitor pattern, which is the object-oriented approach to take operations and data and split them apart and have them live in separate parts of the system. And that is the best solution that's available before pattern matching in Java, but it's not exactly the most readable one. And if you don't know what the visitor pattern is by heart, then that's good. Don't look it up, because we got a better solution now. We can go to pattern matching. If all these ingredients go into pattern matching, switch expressions, type pattern matching, sealed types, patterns in switch, and at the very bottom there's unnamed patterns, which is not strictly speaking necessary, but extremely helpful, as you'll see. The idea here is that we make the page interface, we make it sealed. And then every feature that we want to have is not a method on the page interface, and that gets implemented by the 4 different page implementations, but it's a method elsewhere that takes a page as an argument, and then switches over it, and then somehow tries to handle all the cases. And the point there is at the bottom, the important one, avoid the default branch for maintainability. We're going to go through that now to see why that's important. OK, so let's say I create this sealed interface page, and as I said, I have like 4 implementations, so I only permit these 4 specific types to implement the interface page. That means no other type can do that. I can use this to communicate to my colleagues, but also the compiler that these are the only 4 types allowed to directly inherit from page. And that means that when I switch over a page like this, I have a good understanding that, yeah, I I'm covering all the cases, right? Like I have these 4 cases allowed here, these 4 page types, and all 4 page types are listed here. So that looks about right. Like, it looks like it covers all cases. And this is not just something that we can eyeball. That's something that the compiler understands and agrees with. The compiler is happy with this because it knows whatever page instance it gets, there's 1 case at least for each of those. OK, so, but sometimes we have kind of default behavior, right? Sometimes we're in a situation where, let's say in this case, we only want to categorize GitHub pages. We don't care about the other ones. So we have kind of this default behavior. We want to say, OK, for GitHub pages, issue pages, and pull request pages, I want to execute a branch. But I don't want to do anything specific for everything else. So how can I do this? This would be incomplete. The compiler would be very unhappy with us for 2 reasons, actually. But the result is the same. It says, this is not exhaustive. Please make it so. OK. Exhaustiveness means all possible cases need to be handled. And there are different ways to achieve that in a switch. The first one is you add a default branch, right? That means that everything else that didn't match any of the other cases goes into default branch, so that's all good. The second one is use explicit branches, but you cover all subtypes of a sealed type, which is what we did before. So let's go with option 1. Option 1 just says, OK, categorize the issue page or categorize the pull request page, depending on what it is, but everything else just return category none. That looks good. It does what we want, but the problem is, let's say we add a GitHub commit page as a 5th implementation of the page interface. Now, if we do that, this switch is still exhaustive. Thanks to the default branch, it still covers all subtypes of page. But arguably, we wanted it to stop compiling. We wanted to have a branch that says case GitHub commit page, blah, blah, blah. It isn't there. So what we want to have is a default, is a compile error that says you need to update this switch. And the default is preventing that. So that's bad. That's what I'm getting with this. The default branch is bad because it prevents compile errors that we want, so that we are forced to update this. Compare this to adding a method on an interface. When you add a new method to the interface, the compiler forces you to go through all types and implement that functionality for each type. If you add a new operation in the form of a new visitor, if you use the visitor pattern, again, once you start creating the visitor, the compiler forces you to implement the handling for each type. If you add a new type, then you will make it implement, if you're having all methods on the interface, if you implement a new type, you want to extend the interface. You need to implement all the methods. If you add a new type in the visitor pattern case, the compiler will force you to add to do the visit this method, then you have to implement everything. So you will see that having a method on the interface and also using the visitor pattern, in both cases, you get compile errors whenever you add types or add operations, which is good. So we want this compile error. We want to make sure that when we add a type or we add a configure or we add an operation, that we do get the compiler to point us to all the places that we need to update. In this case, it should have pointed here, but it doesn't because the default branch is making this exhaustive. So the good solution for this on JDK 22 would be to make 2 explicit branches that do the exact same thing at the very bottom there. Because that's good. Right now, if we get the 5th type, if we get the GitHub commit page, there is no branch for it. The compiler will happily point us to the switch and say, hey, look, there's an operation here that needs to handle the new type. Can you please update it? Now, this is the best you can do in Java 21. As I said now, if you add the commit page, you get this compile error, so that's good. It would be nice to be able to do this, to say at the bottom there, well, in case it's an error page or an external page, just make it no category at all. That's fine, right? And in this specific case, this code might make sense, but generally speaking, the problem, it doesn't make sense in the general sense, in the general case. So when you write something like GitHub PR page PR, like you have here, GitHub PR page PR, what this means is on the right-hand side, the variable PR is usable because apparently it's a GitHub pull request page. But if you have this comma there, it says if it's an error page or an external page, then do category none. So which of those variables can you use, ERR or ext? And the answer is none. Because in both, like if you want to use the one, it could have been the other case that triggered this, this branch. So this doesn't work. Like you cannot combine branches with use-named variables, but you can do that with unnamed variables. With this unnamed pattern, you say if it's an error page or an external page, do this, but I will never reference back to that variable. I never need the variable to be of error page or of external page. I'm fine not using it at all, or if maybe I use page at the top there. So that means if you use unnamed patterns, you can combine these branches. And this is the important part. This is where I'm getting with this. This is why unnamed patterns are so important. If you use pattern matching in Java, you want to avoid the default branch. You want to use switches over sealed types so that you do get a compile error whenever something changes, and to make sure that that compile error will be triggered, even if you already had to cover kind of like default behavior, is not to use a default branch, but to use unnamed patterns and combine all the remaining branches into one branch that does like the default thing. Okay, good. So if you want to learn more about this, JEP 456 finalized this in JDK 22, and there's also a video we made on the Java YouTube channel last year, which goes to all pattern matching from the very beginning all the way to the very end, to pretty much what I told you about now. So if you have never used pattern matching and are not quite sure what the heck the guy on stage just talked about the last 5 minutes, this is a good intro to that. Do you have questions about unnamed patterns, specifically the underscore? Okay, like if you do, you can just yell, and I think I'll hear you, and then I can repeat the question for the camera, and then we can go. Okay, let's go. FFM API, foreign function memory API. I will go into much less detail here because I'm not a C person, decidedly not so. So let's talk about foreign memory and foreign code. Foreign memory means memory not managed by the garbage collector, not managed by the JVM at all. It's just, it gives you the memory, but you need to manage it yourself. And the way to do this in a supported way was byte buffer, but that only goes up to 2 gigabytes. It's not very efficient, and it doesn't give you a lot of information on how to, or a lot of good ways to interact with the memory that you created there. And it's also very unclear when those up to 2 gigabytes will ever be freed again for reasons. Basically, the point is that you have a byte buffer instance that references these 2 gigabytes of memory, but the byte buffer instance, the 2 gigabytes will only be freed up when the byte buffer instance is collected. The byte buffer instance itself is pretty small. So nobody knows when the garbage collector might get around to that. It might not for a while, and then these 2 gigabytes that you have blocked elsewhere off heap will just keep being blocked. You could use unsafe, but it is not only unsafe, as the name suggests, meaning you can get a lot of more JVM crashes. We just set the 1BRC slide up there at the end of Josh Long's talk. There's a lot of people who found out the hard way that if you go the unsafe route, you will crash your JVM a lot. So that's one of those ways that it's unsafe. Also, it's not supported. Any minor detail can change in any release. So that's why it's not a good idea to use unsafe. But that means there's 2 choices here, and both of them have the downsides. So the foreign memory API wants to overcome those. It gives you a safe and performant API, and it gives you more control. It has arena memory segment and segment allocator that you can use to create, allocate, and then fill that memory. You can manipulate it, and very important, you have control over allocation, because the arena is something you use in a try with resources block. So when that block is over, the memory gets freed up, so you have control over when that happens. This is what this would look like. You create an arena, and then you go off heap, open off arena of confined, and then you can do a few things. I'm going to get to that in a second. And at the end there, it says the off-heap memory is deallocated here, because that's where the try with resources block ends. Okay, so what could you do in between? Different things. We could allocate some off-heap memory to store some pointers. We could do something with that off-heap data now that we've managed it outside of the GC area of influence. And then we could get it back to the heap later, maybe. So let's go through those steps. Let's do a few of those things. So this code example is too large to ever fit on one slide. So this is the frame, and now we're going to start putting in individual pieces there. So let's say we want to store some pointers to just some Java string arrays. So we say here we create a new memory segment of pointers. I'm not going to go through all the details, by the way. It's fine if you just get an understanding of how this API roughly works. So you're going to get this memory segment here, and then you're going to go through those Java strings to that array, and every time you tell this arena, in this new location, please allocate a UTF-8 string. This is what the string is, and then it will be, and then you set it, then you write it there. So that's the way that you shuffle the data off heap. Now it's no longer under control of the garbage collector. You can do whatever you want. You can, for example, call native code. We're going to do that in a second. And later, if you want to copy the stuff back on the heap, you'll do the same in reverse. You go through the memory segment. You say, at that index, give me something, and then read that as UTF-8 string in Java. OK, so that's how you shuffle stuff off heap, do something with it, whatever that would be, and then get it back. And a very common use case for this is called foreign functions. Foreign code, meaning code that is not Java code, it's not bytecode. And the idea, the solution for that, the current one is the Java native interface, JNI. That is also not great. It involves a lot of tedious artifacts, like you have to have header files and implementation files, and the tooling is not great. It doesn't really bridge the type system gaps, and so just much like the byte buffer, it's a decent solution, but it has a lot of shortcomings, and now it's time to fix those. So Project Panama introduced the foreign function API, which is the second half of FFM, foreign function and memory API. Wait, actually, it's the first half. So the FFM API was introduced to overcome those shortcomings. Specifically, you would use var handles to call into the native code, but method handles. But because nobody wants to write that code by hand, the tool JExtract will generate that for you. And then the idea is you have a native library somewhere, you run JExtract, you get a very low-level Java wrapper around that, and then you can create your own Java wrapper on top of that, which is like a more decent Java-E API. And then when the library underneath updates, you run JExtract again, and you get a new version automatically of this little wrapper. And then if there are any things that don't fit, any incongruencies between the old and the new API, then you will get compile errors in Java between your layer and the low-level code that was generated. And that means that you can stay much more in Java space when you're handling these updates, for example. OK, so what would that look like? I'm getting here the native linker. I'm getting a default lookup. And then I'm saying, look, I know that there's default lookup would give me the standard library. And then I know in the standard library there's a radix sort method. So I'm getting a method handle to that foreign code, to that C code that lives in my operating system. Then I do the whole song and dance with the Java arrays that I did with Java strings that I did earlier. I have the array here. Then I move everything off heap. And I have this memory, these pointers here. These I got from copying the stuff off heap. And now I'm invoking that foreign function pointing to that memory segment, and then later I'm going to copy the data back. So this would be one use case. If you cobble the code together, you will see how to get data off heap, how to run radix sort, and then get data back, which is, of course, just a toy example, right? But something that can get you started if you're working with native code. OK. The interesting thing here is that while it was in preview for a long time, Java 22 finally finalized the FFM API. But there's still more to do. So while this block is now done, Panama is not done itself. It wants to work on that to have more user-friendly performant mapping from native memory to Java records or instances. This might be called segment mapper, so I've heard rumors about that. JExtract and surrounding tooling needs to be improved, and there's more. So if you're interested in that, go to the Project Panama mailing list, which is the bottom link there. The slides will be, I will show you the link to the slides later. So you can click all of those links. Also, otherwise, JEP 454 finalized this. So it has a lot of information about this. And there's a great video by the creator of the API, or the project lead of Project Panama, Maurizio Cimadamora, who did a lot of that. OK. Any questions about the foreign function memory API? Please don't. Good. So my story about learning, I might have already told you this. So my story about learning C, C++ is that I never learned that in school or in high school or university. And being a Linux fanboy, despite the machine I have to use now, I was Linux at home. I wanted to, maybe contribute. I'm kind of open source guy, so maybe I can contribute there. So I set aside one weekend. I need to learn C to get into this, to start learning the language that this operating system was built in. And after like a couple of hours, I was like, nope. I basically did the table flip, and I said, I'm not going to learn a language that makes my life so much harder. And that was the end of my C++ story. So that's why I'm not the most well-versed about this. But yeah, if you do deal with Java native interface, I'm pretty sure that the FFM API will help you make that easier. OK, let's talk about launching multi-source file programs. But I want to bet this into a larger a change that is happening within Java. So Java and the ecosystem is very mature. We have a very refined program model, like visibility and synchronized and what's the I forgot. There's another modifier that you can do on a volatile, for example, stuff like that, right? we have all kinds of programming concepts, like not only do we have classes, but also interfaces, oh yeah, and abstract classes, and enums, and then there's records, and soon there might be value types. So, you know, you can see like it's a refined program model. We have very detailed tool chains with tools for every step of the way. We have a rich ecosystem with lots of great build tools and web frameworks and testing frameworks and IDEs and all of that. And this is all great. I'm not complaining about any of these things. That's amazing, and one of the reasons why the Java ecosystem is going so strong is that it has this capability of modeling the complexity of the real world correctly because it has all of this detail. But that is a problem for new beginners. This is not easy for people who want to get into Java. So if you want to, if you want to show your kids how to program, even though you are a Java developer, I assume, maybe your first idea is not actually Java, and that would be better if that would be different. It needs to be approachable for students, but also for people already developing, right? Front-end developers who maybe want to go to the back end, people who learned a different language and now want to switch to Java, or people who learned Python and MLAI, and now they want to, write a product around that, or write a whole project around that, and they're picking Java for that. There's a lot of people who Java should be approachable to, and we don't need to forget that, even though that we are pretty steep in this ecosystem. So Java needs an on-ramp, some way to get from, I don't know Java, to, okay, like I'm halfway decent into this, and I'm doing steps. Doing things, solving problems. And this is a part of that ramp that I want to talk about. Simplified main method and class, the single source file execution and the multi-source file execution. The first part is that code should get simpler. So instead of having public, static, void, main, string, bracket, bracket, args, maybe we just remove all of that, because none of that is strictly speaking necessary. It's an artificial requirement that we can just change. And so that's what's being done. In JEP 477, this is a preview in Java 23. And what you see at the bottom there is not an excerpt of another file or of something larger, but this is like literally the only thing you need to do in Java 23 with preview features to run like a small Java program. Just open a new file, type void main this, and then you can run it with Java, JDK23, right? Java -- enable preview main.java. And the -- enable preview is only temporary until it's no longer preview. So that's good, but we get a little bit more even. So we have, as I said, like this is the whole class. You don't need to have a class body around that. If that's the case, it's called, well, what's called changing. So I think it's called a simple source file now. So it's not longer an implicitly declared class, but that the details will have to be shaken out over the next couple months. What we also get in such a simplified main class where we only have the main method but not the body around is we get automatic imports of the print, println, and readline methods, which means we can now write this and are no longer the butt of the jokes of the entire developer community because we have to write system.out system println, even though nobody ever types that, right? We just go south or whatever your IDE does. But again, the beginners, maybe not in IDE, that's really good for them, right? So that's good. What we also get for free is imports of everything that's in the Java base module. So I can just use list without having to know where list comes from, and even worse, without using list the first time and then being asked by my IDE, you mean Java AWT list? And you're like, yeah, that sounds about right. Probably that's the list I want to use. Right, so that's good. So we get these IO methods for free, meaning they're all already imported, and also we get the whole Java base module imported, so that's good. So now that you have such a very simple source file, you can just store it at Java, as I said, like this. It doesn't, sorry, this already works because it's final since Java 11. So if you have a regular main Java file, which is like a full class, then you can get rid of the enable preview. This has been a feature since JDK 11, so that's pretty cool. And now we get to JDK 22 because it added this. Before this Java file here, the source file, oh right, you're seeing that I'm throwing a source file at the Java binary, right? The Java launcher. There's no compiler involved here, at least not explicitly. Implicitly, of course, what happens is that the JDK there knows that it has a compiler on board, compiles everything in memory, and then runs the resulting bytecode from memory. So there's no additional Java C step that I'm hiding here. What you can do now is you can do that with several files. You don't need to have just the one file. So if main.java references helper.java, and even if one of those two references classes from a jar, then where do you get the jar from without a build tool? But let's not go there. It's a problem for another day. Assuming you have somehow magically gotten this jar file from somewhere, you can now do this. You go Java class path, there's the lib folder, look in there for everything, and then start main.java. And then Java is smart enough to figure out, the Java launcher is smart enough to figure out why compiling main.java, or it references helper.java. Where do I find that? Oh, it's here. That's all good, so it finds that file too. And then it finds the reference in the jar as well. So that means there's now a very natural progression. You can just start with the main method, and if you need arguments, you just add the string array args. And if you need to organize code, you can start adding methods. And if you need to share state, you can add fields, because these simplified classes can also have fields. You can explore JDK APIs. All the imports are there for free. You can explore simple libraries, assuming you get them from somewhere. And you can split this into multiple files. So once the students or the experimenters or the teachers progress is far enough that it doesn't reasonably fit into one file anymore, split it into several files and keep going. You can use visibility and packages with this as well. It does not need to be flat, that example that I showed you. But the best part about this is it doesn't have to be that order. You can start really simple, which is main, and then whenever the learner or yourself are running into limitation, then you take that step. You say, okay, maybe the first thing I do need is not the string array args, because I'm passing command line arguments. Maybe the first thing is to figure out how to create a list and stream over it. Right? So you can pick pretty much whatever you want from this list. And I think that's the best way of learning. Having a tool set, trying to solve a problem with that, realizing that something is missing, and then being told, this is the one thing that you need. So instead of going, okay, so let's talk about visibility, let's talk about static versus instant, let's talk about classes, before you get to write your first line of code. I'm not saying those things are important. I'm saying those things are not important to know before you write the first line of code. With this, you can do it the other way around. Just be like, okay, this is the minimum amount you need is what is a method. Here, now you know what a function is, or what a method is. Here you have one. Write stuff in it. So I think that's pretty good. Lots of things to follow up on if you want to. JDK enhancement proposals and a bunch of videos you made on that. Do you get questions about this? Yes, first one. Why still void main? Why not just remove that, just write top-level statements, right? So one important part here is that you should never have to unlearn something. You should never learn something that works in one context, and then in another context is somewhat different, doesn't work anymore. And the problem is that the behavior of method local code isn't quite identical to what the behavior in our class would be. So let's say, for example, I want to create a variable. If I have a variable, then this behaves different from a field under certain call conventions. So when I have a reference that variable or that field, there can be differences in the exact code. So if I put this code into a method, into a blank top-level statement, then I would have to decide, are those fields, are those local variables? And then there might be a slight different behavior. So the decision that, okay, well, that was one of the reasons, to not go into those details, but just say, okay, this is a method, and everything you learn is always true for whatever you do within a method. And then the other part is that a method seems like a good atomic instance to say, we're not going to separate further, we're not going to split further. This is like the smallest piece that you have to contend with. Because you're pretty soon going to, unless you just do ifs and invariable declarations, you very soon will call a method anyway. And so at that point, it's good to know what a method is. So if that makes sense. More questions? OK, let's go to something that's actually new in Java 23, which is presumably why you're here. Let's talk about Markdown and JavaDoc. So OK, I want to ask, what is it today? It's Thursday. So you mostly just came before the day, right? So who has already written some Java code this week? OK, so for the audience at home who can see this, for like 80% at least of the people. Can you keep your hands up, please? Now, can you keep your hands up if you also wrote some JavaDoc this week? Every time you do that, another person thinks like all comments are failure and follows Uncle Bob on Twitter. OK, so I think there should be a little bit more JavaDoc in your life, but I'll leave that to you. I think JavaDoc is actually a pretty good tool and a pretty good communication tool to your colleagues. Specifically, if you keep it simple, I really like that at least have like a paragraph, 2-3 sentences on top of every type that explains what this type does. And I know you think you know what it does because it's called user. What else can it do than be a user? But you know your own code. You know that this is more complex than that. So having a short paragraph up there that explains what a type is about, I think is really important. It's also a good starting point. It's also kind of the sweet spot where it's easiest to write JavaDoc, because once you write more complex documentation, it goes awry. There's lots of stuff that you have to know or ignore. For example, I always forget where the paragraph goes. Basically, at some point, my IDE is yelling at me, and I try to fill it in. Lists are verbose, code snippets are terrible. Most of that is down to HTML, though. It's not really JavaDoc's failure. Many of these issues are down because I have to write HTML manually, which is not something that's particularly fun to do. Markdown is more easy to write, right? You don't need to care about paragraphs. Code snippets and blocks are super simple and look good. Lists are simple. Tables are still terrible, like in HTML, but maybe a little less so. And whenever Markdown runs out of steam and you need something more complex, you can always just embed HTML and it will pass through any Markdown parser, and that's good. So that means Markdown is it's a tool that's easier to write and arguably to read than HTML or language. But it's also very widely used and known. More people use Markdown than, write and read Markdown directly than HTML. A lot more people, right? Like everything from Slack to Jira to GitHub, they all use some kind of Markdown syntax. So that's good. Like it's a style to write documentation that is more well known, that is easier in most cases, and where it doesn't work that well, you can just pass through the complex thing that you would have done before anyway. Okay, so JavaDoc now allows that. You can write Markdown comments. You would have to start them with 3 slashes, backslashes, forward slashes. Yes, forward slashes, 3 slashes. You would use command mark 0.30, which is one of the latest versions of that spec. And then there are 2 more things that I'm going to go into in a second. You don't need to be able to read this. This is from the JEP. This is on the left-hand side, regular JavaDoc. On the right-hand side, it's with Markdown. And the text was not reflown to keep the changes minimal. But what you will see that there's a bunch of small things that are different, right? Like instead of writing @link, you just use the square brackets here. Instead of the UL and LI elements, you just do the Markdown list. It's very easy to use something like emphasis or code snippets. So it just makes the whole experience a little bit easier and more straightforward. Let's look a little bit behind the scenes. Why the 3 slashes? This would have been nice, right? Like Markdown already allows this. Markdown has this thing where you have like 3 backticks, and then it starts a code snippet, but you can do 3 backticks, and then you name what language it is, and then you get code highlighting maybe, depending on what parser is behind that. So wouldn't that be cool if you could just do this, and then we could also in the future then maybe go to ASCII-Doc, right, or whatever else. So why the weird new 3 forward slashes? Well, there are 2 reasons. One of them, which I was not aware of at all, is that this leading asterisk here is optional. Like if you have one of these blocks and you hit enter, you actually see you're still in a comment block. You don't need this asterisk here, but still, like it's always there. So I thought it was kind of needed, but it's not. And that means what's this now? Is this like a Markdown list, or do these asterisks belong to the Markdown block? To the comment block. And this seems ridiculous that for this reason you might not get this feature, right? But it is true. If you write a compiler, if you write a parser for this, it needs to be 100% exact. It can't just be like winging it. But there's a more important one, which is within those blocks in JavaDoc code blocks, in JavaDoc documentation blocks, we want to have more code blocks. And those code blocks sometimes contain documentation themselves. And this will that not work. So what I'm doing here is I'm doing the fictitious Markdown, blah, blah, 3 backticks Java, and now there's a Java inline comment that ends like this. But that doesn't work, because a JavaDoc comment is not allowed to contain this. This character sequence ends the ends the JavaDoc block, which is visible by my code highlighter. Actually, my code highlighter does the right thing here, because of course this is written in ASCII-Doc, so there's a code block around this, which is highlighting this as Java code, and it notices that the Markdown block, that the JavaDoc block ends here, and then this is just random characters. That's why it's white. Okay, so that's why we don't get that. That's why we have 3 slashes we need to contend with. They don't have these issues, and also it's not a good reason to adopt it, but it's a good reason to look into it. And it's also a nice bonus. Other languages kind of use this already, like similarly. So that's kind of good. And also, you don't have to change the Java syntax, because the 2 slashes already escape the parsing. OK, good. So let's talk about a few details. Let me quickly. Yeah, let's talk about a few details. The first one is, if you want inline code, you just use the backticks. Now, how do I use backticks directly? Because usually this would escape, because it's ASCII-Doc. So it usually would get, this took me like 5 minutes to fix, to get like actual backticks on the slides. You can also use code blocks with fences. So this would be the way to get Java highlighting. To get this rendered as a code block. If you want Java highlighting, you need to do at least 2 things. One of them is you need to add the language there, and then you need to find some front-end-based JavaScript code highlighting thing that you can add with the add script tag, add script command line argument. So that way, then your JavaDoc references that JavaScript library. And then also, you probably need to figure out how to make it aware that the Java blocks should be rendered as Java, but you'd have to figure that out The point being is that this makes it very straightforward to have code blocks in your JavaDoc. References are just the square brackets. This is actually in Markdown, this is known as, I think, the reference link syntax, which you can always do. Most of us don't use that, but you can always use that. Like in Markdown in general, you can just put square brackets around whatever term, and then at the bottom you write, again in square brackets, that term, colon, and then a link. And then that will be linked. That always works in Markdown. Basically what you get here is that everything that's like a program term will basically be linked at the bottom, so to speak, right? So you can just reference classes or modules or packages or whatever, and that all works. So these are all links. That's important here. I could click on these. You can see it a little bit better here, because if you do it like this, you will also get it set as code. But you don't have to. You can also use the full reference link syntax to do that. Then you don't get the code highlighting or the code formatting. And then you can see here that these green things are links. OK, so links also a little bit easier. Tables, again, I think they're better than HTML tables, but they're still terrible. I would recommend something like tablesgenerator.com or similar pages. You can just write live table generator HTML. You'll find some page. What it does, it's a super minimal Excel-like surface where you just say, OK, one more column and one more row, and then you type everything in, and then it just gives you an HTML table, which is what I do when I have to create one. If you want to have more advanced tables that have features that Markdown does not support, again, you can always pass through HTML, and so that would be the way to go. Tags do still work. So if you want to reference stuff, like here, this is something where the JLS gets, the Java language specification gets referenced, and here's an impulse spec reference, then that still works. So those references are no problem. And also, the text that is connected to them is also parsed as Markdown then. Right? So this nothing would also be emphasized. JEP 467 goes into more details about this, and then my colleague Anna made a great video about as well, going to 5 to 10 minutes, into more details of how JavaDoc uses Markdown. OK, this one will be quick, and then we have to see whether we can pick something from the optional list. OK, so generational garbage collector. Let's first start talking about garbage collection and ZGC in general. So every garbage collector has to do some things better at the cost of other things, largely speaking, trade-offs, right? It can optimize for certain things. ZGC, let's ignore the generational for now. ZGC is optimized for ultra-low pause times. That's its most important goal. And it can handle huge heaps while doing that, and that's all good, but it comes with a little bit more memory footprint and CPU usage in exchange for having this ultra-low pause times. In JDK 21, ZGC became generational, meaning it leans on the generational hypothesis that most objects do in fact die young, and those who don't die young grow very old. If you've never heard about this, think about your regular Java backend application kind of thing. You boot it up, you Spring boot it up. Spring Boots does like a gazillion things, or whatever Spring does. And then you have like a bunch of classes around, right? Like your controllers and all that stuff. Those will exist till the end of your program. But then every new request that comes in, you spawn up a few new things, you'll create a few new objects, send them to a database, get them back, whatever. At some point, you send out the response, and then those objects are no longer needed. They would die, and they would be collected in the next garbage collection. So that's what I mean. Most objects die young, and the ones who don't usually live for a very long time. That's true for many code bases, for many projects, not just Java, by the way. And the garbage collector can make use of this by managing generations, and by making sure that the stuff that's new is just all in one place, so it can all be emptied out easily, and everything that's old is elsewhere. ZGC didn't do this before, but it can do it now. The generational mode has been added. I want to say in 21 as experimental, but I'm not sure about that. The point is that in 23, it is now the default. Netflix publishes a series of blog posts on this, and they have really, it's a great article. I can highly recommend to look at this. If you just type Netflix GGC, you will find it, but there's also a link here. I want to show you two graphs out of context. If you think like, this is way too little detail, please read the blog post. I just want to show you that this is promising and that it is worth giving a try in your project. I'm not saying because of this you should use it. Sorry. OK, so what we see here is, let me see, I think average memory utilization, there we go. And The gray bar is from the last time period, and the blue line is live from the current time period. And they all look very similar for most of the graph until generation ZGC is activated. And here you can see like a slight drop in like 10 to maybe 20% memory utilization that improved with generation ZGC. Here's another one, which is different percentiles of, what was that, pauses? GZ pauses, yes, different percent of GZ pauses. The graph doesn't end here. It continues, just the numbers got so low that they don't show up on the graph anymore. You can see like a small blip there occasionally. That was the pause time outcome of switching to generation ZGC. Suffice to say that Netflix was super happy with this. They're not the only ones to talk about this publicly, but maybe the most well-known ones. So if you do care about pause times of your application, I recommend giving ZGC a try. If you're just using G1 as a default garbage collector, that might be good for you. But try ZGC, try generational ZGC. Measure those things if you can in any way, shape, or form, and then make a decision based on that. So in JDK 23, the generational mode is now the default for ZGC. Now, just to make sure that I don't confuse people, the G1 garbage collector is still the default garbage collector on Java, on JDK, and it's probably going to stay like that for the foreseeable future. The reason is that within these trade-offs, we can largely say Parlog GC only cares about throughput, ZGC only cares about pause times, and then G1 balances those out. That's very, very simple. But that's the reason why G1 is the default, because it sits in the middle of this. So if you're doing batch jobs, nightly jobs where you just run through a bunch of files and put something in a database or whatever, or crunch numbers, you should totally look into Parlog GC for that. If you're really interested about pause times, if like the 99th percentile is the most important thing for you, you should really look into ZGC and then now generational ZGC. There's a lot more here, lots more links. And that's also the article there again, bending pause times to your will with generational ZGC. It's slightly avatar inspired. OK, good. So we are, let's skip all of this for a second here. Let's go here. Right, so we are done. We have 5 more minutes, which means we can pick one of these topics, probably only one. And the first person to really loudly yell what they want will get their wish. Gatherers, I think is what I heard. Or a bunch of you things at the same time. OK, let's go over stream gatherers. So streams are good. I like streams. I love to use them. I even love to overuse and abuse them. I frequently get yelled at by my friends when I show them the code that I write for demos. So yeah, anyway. But there's stuff that's missing from streams. And if you use them somewhat regularly, you notice that occasionally there's like this one intermediate operation. It would be really good right now, like sliding windows or putting things into fixed groups or whatever. There's a bunch of these things that could be added technically, but they aren't there. Let's take a little detour. The same is true for terminal operations. Streams do not have all possible terminal operations that you consider. But what they have a bunch of them, right? They have like something like reduce and toList since 16, so that's all good. But they have a general terminal operation called a collector. So the idea here is that whatever a terminal operation does, it's just a bunch of things. It's always the same kind of things. So you could just generalize that. We call it a collector. And then we give you a bunch of implementations for that, collectors to set, collectors to list. That's where they are coming from, or to map. Those all already exist. And then there's one specific extension point on the Stream API called collect, where you plug in your collector. Right? So the concept of a terminal operation is enshrined in this concept, or in this type of a collector. And then you can create that and plug that in, and then it does the thing. And for intermediate operations, the gather API is doing just that. It generalizes what an intermediate operation does, calls that a gatherer, gives you a bunch of implementations that you might need, that might come in handy if that's the one that you need. But if you don't, you just implement your own. And then you plug that into the stream.gather method, and you get your behavior. So this is what this could look like. It doesn't matter what scan does. Scan is a static import of some method somewhere. So somewhere I have my gatherers.scan, no clue what it does. But the way I'm using it is I'm saying stream of A, B, AC, FBS, whatever. And then gather, that's the new method. This is the gatherer that needs to be plugged in, and then for whatever comes out, that's system.println. There are 4 building blocks to records, to gatherers. Let's start with the most important one, the only required one, which is the integrator. The integrator takes in a state that we're going to ignore for now, the current element that is being examined, and then the downstream. The downstream you can think of as the next method in your stream pipeline. So here, downstream would be the for each. And the task is, take the state, again, that we're going to ignore, take the element, then potentially update the state, and then emit 0 or more results downstream. This is an integrator that does nothing. So if you look at my slides and you copy-paste stuff into IDEs, you will occasionally get the problem that I don't use wildcards a lot. Like, there's no extends and super here. It's limited, space is already limited on the slides, so I don't want to go overboard. So this is definitely the case here. So if you copy-paste this code, you might have to add some extends or super somewhere. OK, so what I'm doing here is I'm creating an integrator that takes the state that I'm going to ignore with the underscore, an element and the downstream. And all it does is it takes the element and pushes it downstream. That's all it does. So it's the simplest possible integrator, and I create a gatherer from that. And now I have a gatherer that does nothing. It just like gather dot transparent does nothing. Sorry, gather and then this import. Let's do something more interesting. Let's reimplement stream.map. So my map function here my map method has to accept the function that I'm going to use for the mapping. And my integrator, again, ignores the state, takes the element, takes the downstream, applies the function to the element, and then pushes it that downstream. Okay, and if you're interested in gatherers, I highly recommend, that's one of the first things I did, just sit down and re-implement map, flat map, filter, like all these box standard intermediate operations, they can all be expressed as gatherers. And it's kind of good to get to use to get to know the API that way. And by the way, I'm returning something here. What I'm returning here, I did the same thing here implicitly, is an information whether the downstream wants to see more elements. That's what I need to return there. OK, there are 3 optional building blocks: initializer to create a state, a finisher to wrap up at the end of an operation, and then a combiner that combines several states. Unfortunately, we're running out of time, so if you want to ask me how to do that, you can just grab me whenever you see me here at the conference. I'm around all day and love to talk more about this, so that's all good. Also, any of these questions or any other question you might have about Java, I'll do my best to try and answer them. Just a few slides of 22 and 23. These are the 5 final features that 22 and 23 added. 22 newly previews these. These were introduced now, primitive patterns and module imports. We talked about that a little bit when I said that the simplified main file can read all the types that come from a module. This is a module import. So this gives you an idea there. These are all the features that are pre-features that are being continued. I put string templates on here because, if you have questions about why string templates were kicked to the curb, I can tell you that as well. These are all the previews that are being continued, so you can see a lot is going on in there. So it's not as explosive as 21 was, which has like the pattern matching basics and virtual threads, but it's definitely no slouch. They both continue Java's evolution, and you can get JDK 23 now at jdk.javanet/23 and experiment with that or put it into production if that's something you do. And with that, I want to thank you very much for your attention. So as I said, if this, you can ask me all the rest of the day. If this kind of stuff interests you, go to insight.java to follow Java's development. Go to dev.java to have a look at what it looks like now, and then youtube.com/java for videos from me and my colleagues about all of this. Have a good one.